Welcome everybody. It is week 15 of the spring semester 2020 for Social Work 110. I have a new background for you. Looks like they've redone some operations for this program, so it's going to look a little different, but it'll still be about the same content, so we'll keep moving forward. So if you're watching this, today is April 27th, 2020, and we have 4 things to move through today. First is announcements. Second is presentation requirements, which I'm sure a lot of people have been kind of talking about, or, I've certainly received a number of emails about it, so we'll get to that in great detail. We'll do a little bit of review. That's Roman numeral 3, and then we will do a simple linear regression exercise. One of my new little features here. I can just kind of scroll off of that and bring you to the announcements right away. So the announcements, what are they? Well, one's not too surprising to you. I've been talking about it for weeks. Exam number 3 is this Wednesday, April 29th, 2020. As you know, we'll be starting the test at the same time we would have class, unless there's some kind of accommodation or something you're talking to me about that would somehow change that. If you have an accommodation, you will be given, of course, the amount of time that you require per the agreement. So that's the first thing to say. And again, I don't think this exam is going to be coming as a surprise to anybody. I've been talking about it, my goodness, since probably before all of this started. But nonetheless, I've been talking about it every week. It seems like every class. So again, no surprises here. Exam number 3 is going to be about t-tests and correlations. I'm not really going to do almost anything with regressions. The only thing you need to know is what regressions are. I don't think we really need to go into any more detail than that. And so that is something that, again, no one should be surprised by this. Roman numeral 2 presentations. Okay, obviously, this is not a semester where we're going to be able to do things together, I don't think, in any way that seems super practical. So what I'm going to go ahead and suggest that we do is, when I describe the presentations to you, make sure that you get them to me by May 8th. This is 10% of your grade, but I'm going to be spending some time today talking about presentations and what they entail. And then, of course, the last item here is number 3, which is exam number 4, which is an optional final. If you're satisfied with your grade by the end of the classes and you don't feel like you want to try to make any improvements because it's fine the way it is, then don't bother taking the optional final. However, I will be grading 3 out of 4 finals. So obviously, if you decide to take the final, the optional exam 4, there will be 4 for me to pick from, and I will take your 3 highest scores. So I will, in essence, be replacing, if indeed you get the highest score on your final, I will be replacing the lowest score you had going into the final. But taking the final does not count against you. So obviously, if your final was the lowest grade, I just wouldn't count it at all. But if you, in fact, have a lower grade than the final on a previous test, I will substitute the exam number 4's score for that final. Okay? So that's hopefully, in terms of announcements, information that you need to know and make sense. And I know that a lot of questions are going to come up about presentations, and I'm going to go ahead and answer that as best I can in the next segment. And now let's go ahead and go over the presentation requirements, which I know a lot of you have asked about. So I'm going to do this step by step and hopefully as clearly as I can. I've written this all out, and I will also post this as a Word document in an announcement and on the modules and anywhere else I can put it. So it might be posted to, I don't know, maybe it's trailing a blimp. It could be written in the sky by a plane. I don't know what else I'm going to do here, but I might do other things too. Okay, let's just start at the top. These are the presentation requirements. And by the way, I noted that I had the incorrect date posted initially on the Canvas. It originally it said May 1st, which was inaccurate. Should be, as you saw in the announcement segment previously, it's actually May 8th, which would be the last day of class. So again, it's not the end of next week. Okay, sorry about that. If it gave you a shock, it wasn't intended to. It was a little bit contradicted by the module, but I wouldn't even have expected you to know that, so it's okay, no big deal. Let's go ahead and take a look at what the purpose is. This assignment is intended for students to present what they have learned by synthesizing an original fact pattern with a statistical application. So again, this is something that you're going to come up with yourself. What are the points available? 30. It's 10% of your final grade. Here's your description for each part of this. There are 3. So this assignment consists of 3 parts. Part A, worth 10 points. Students will be able to come up with an original social work fact pattern and generate random data for it. Let me just stop there. This whole semester, you've seen me give you fact patterns in assignments or quizzes or class or participation sheets. I made them up myself. I made up the data myself. I didn't discover it anywhere. It was just stuff I kind of made up. So here's what I'm going to say next. Oops, I'm going to actually try to highlight this if I can do that. Okay, creativity counts here. In other words, I want you to come up with a fact pattern that would fit with the field of social work and is something you might be interested in. So I said, pick something you are interested in within the field of social work. As an example, I have used in the past, I've worked with the severely chronically mentally ill for quite a while, and I decided I was going to do a correlation as an example, and I might post it as an example as well in the near future, where I just said, okay, so social workers are not allowed to use medication to treat clients, but we can use non-medication type of interventions with clients. So I rigged a fact pattern where I said, something like between 10 and 12 people participated in a program that dealt with mindfulness and challenging psychotic events. And I wondered how they did as a result of this. So, for example, participant number 1 would have been in the program for 5 classes or 5 interventions, and their distress level or their anxiety level had come down on a scale of 0 to 10 to a maybe 5. I made this all up. So the point of it is that you too will be making something up. And so for part A, you'll be coming up with your own original social work fact pattern, and you'll be deciding whether or not you want to apply chi-square or correlation analysis. Okay, you get to pick those 2. We're not doing t-tests for this one. We're just going to pick which of these 2 you're going to be able to use. The analysis is a little more rigorous for these guys. Okay, part B, also 10 points. Write out your statistical analysis, which of course will give you a calculated value for your selected statistical application. However, you cannot simply find a result through Excel. I taught you in the last couple weeks how to use Excel for both correlations and chi-square. That's not applicable here. I would like you to see you write it out. So you're going to create your own fact pattern. That's part A. Okay, you're also going to be choosing chi-square or correlation, and you're going to be writing out how you found whatever your calculated value is. And then part C this is just absolutely what we've been doing for the last 3 to 4 weeks with just about everything we've done. I'd like you to answer these questions in relationship to your fact pattern. With respect to your specific fact pattern, respond to the following questions. What is the null hypothesis? What is the calculated value, which you will discover in part B? Okay. What is the degrees of freedom? You're going to have to know that. What's your critical value? You can find that on the chart. After comparing the calculated and critical value, what shall be done with the null hypothesis? And based on your conclusion, what will the p-value read? Is it greater than 0.05 or less than or equal to 0.05? Now, you might be asking, okay, great. I understand what the content is. Where do you want this? How do you want it? Okay, here's my last sentence to you. All of this should be written out and displayed clearly. Okay. This could be as basic as a Word document or as elaborate as a PowerPoint presentation. Frankly, as long as you have all the parts, I don't mind how you do it. Keep in mind that this assignment originally was designed to be presented to the class, but we don't really have that option right now, at least not to my satisfaction. So it's not going to work quite the way I wanted it to. But I knew that kind of going into this whole quarantine state anyway. So what I would like you to be able to do is I'd like you to be able to create this and have it done and submitted to me by May 8th. If you want to do it anytime before May 8th, that's fine too. That just means probably get the grade back to you sooner. However, I will say that in the past, and again, I don't have a preference here, but students kind of had some fun with this. And what I mean by that is they chose, maybe some of them did like a PowerPoint. And when they did a PowerPoint, they gussied it up with pictures, or they figured out ways to use, they would intersplice tables, or they would snip a Word document that had their calculations on it. They would transpose that into the PowerPoint. It doesn't matter. Do what you're comfortable with, but I would say that as much as you can choose something you're interested in and have fun with it, the better. Hopefully this is something you can kind of enjoy. So I'm going to make sure that I put this up here, even though I've said it several times now. Due May 8th, 2020. Okay. Again, this is not something that you won't have time to do. You're going to have plenty of time to do it. But I do think that the hardest part here is not going to be the math. It's not. The hardest part is probably just going to be coming up with a fact pattern. I think that that's going to be the hardest part of this. And the other thing is that when you generate random data, I don't care how you do that. You can roll dice. My favorite technique would be to put a bunch of numbers on the floor and have my cats step on them and just write them down. But you can do whatever you want. You can throw darts at a board. You can have your kids draw from a hat of numbers. You can count, treetops. It doesn't really matter. Just as long as you're randomly generating the data. And I think that, again, that's not, I think that part's not even going to be that hard either. It's going to be coming up with and formulating a fact pattern. I think that's really what's going to be the most difficult part with this. But again, you've got plenty of time. And how you want to display it, written out clearly and displayed clearly, that's going to be up to you too, as long as I understand that you completed parts A, B, and C. But again, as much as you can, like I said several times now, try to have fun with it. Try to have fun with this assignment, I had some really interesting ones in the past. Someone had even done a presentation on cat therapy because you know why they knew that, because I'm always talking about cats. But anyway, again, have some fun with this, okay? Give it a run. All right, I'm sure I'll say more about this later, okay? But I will also cut and paste all of this onto a Word document. I'll post it in an announcement. I'll put it in a module. It'll be available to you, so not to worry, okay? So I have 6 review questions for you today, all true and false, and they incorporate both simple linear regression questions, which we began to look at last week, and I threw in some t-test correlations as well, just for practice. So number 1, true or false, simple linear regression requires a correlation that is statistically significant. Okay, true or false? Okay, number 2, true or false? Simple linear regression allows us to locate a y value by plugging in an x value into an equation. I think it should be a x value, not n. Nonetheless, regardless of grammar, hopefully you got the gist of the question. Okay, number 3, true or false, t-tests, should be plural, t-tests and correlations are bivariate analyses, but not simple linear regressions. Okay, true or false, t-tests and correlations are bivariate analyses, but not simple linear regressions. Okay. Number 4, true or false, t-tests and correlations both are looking for differences in averages between two groups. True or false, number 4, t-tests and correlations both are looking for differences in averages, okay, between two groups. Number 5, true or false, correlation coefficients allow you to find the direction and strength between variables in a data set. Okay, correlation coefficients allow you to find the direction and the strength between variables in a data set. And number 6, true or false, simple linear regressions use variables at the nominal and interval ratio levels of measurement. To repeat, true or false, number 6, simple linear regressions use variables at the nominal and interval ratio levels of measurement. Okay, take a minute if you haven't and reflect on those, and we'll come back with the answers. We're back now with the answers, and I found out that in terms of the format here with the new structure of this particular program I'm using, I have to I have to keep the numbers and the answers close to one another. I can't give spaces in between them or they'll start readjusting the numbers. So a little inconvenient, but we'll just adapt. So here's how we'll adapt. Let me go to the first question and then I'll highlight the first answer. So question number 1, true or false? Simple linear regression requires a correlation that is statistically significant. The answer is true. Oops, 1 second here. True. Okay. Simple linear regression only applies to correlations that are statistically significant. Okay. Take a look at number 2. Simple linear regression allows us to locate a y value by plugging in an x value into an equation. That's exactly what you end up with. Okay, and go ahead and highlight that. So true, simple linear regression allows us to locate a y value by plugging in an x value. That's of course after you found and created the equation, okay, as I showed you last Friday with the PowerPoint presentation, but we'll go over it again. Okay, number 3, t-test and correlations are bivariate analyses, but not simple linear regressions. Not quite. That's not quite the right answer. False. T-tests, correlations, and simple linear regressions are all, let's go with all, not ill, are all bivariate analyses, okay? And indeed they are. In fact, simple linear regression can't help but be one because it applies only to correlations, which are, by definition, okay, they already are bivariate. So you couldn't do simple linear regressions without correlations, which are bivariate. So are simple linear regressions. Okay. Take a look at number 4. T-tests and correlations are both looking for differences in averages between two groups. No, I'm sorry, that is false. Okay. It goes like this. While t-tests examine for differences between the averages of two groups, correlations test for similarities between the values of two variables. So we're taking a look with correlations at more or less a relationship. Okay, remember the language there: relationships, correlations, okay, associations. That's talking about similarities. Whereas it's starkly mentioned in the null hypothesis of t-tests, they're looking for differences between averages. Okay, so let's move on to number 5. Correlation coefficients allow you to find the direction and strength between variables in a data set. Okay, here's number 5 in terms of answers. Let's see if I can get that for you. Capture the whole thing. Okay, true, correlations allow you to find the direction and strength between variables in a data set, and that's why you have either the positive or negative value, and then also how close you are or far from 1 plus or minus. Okay, we've gone over that a number of times. Take a look at number 6. True or false, simple linear regression use variables at the nominal and interval ratio levels of measurement. No, that's false. Okay, simple linear regression uses only variables at the interval ratio levels of measurement. Same as correlations. Again, remember, simple linear regression is based on correlations. It's only t-tests where you're going to find the nominal and interval ratio, okay, among these three. So again, something to pay attention to, okay? But hope you did well, and hope you're flying through this and it's beginning to resonate with you if it hasn't already. Okay, we're going to pick up where we left off last week. I introduced you to the concept of simple linear regression with the PowerPoint presentation. And I'm going to return to one slide from that presentation, and then I'm going to move into an older fact pattern from when we were doing correlations in hopes that it will be familiar to you. So I'm going to go in that order just as I stated. So once I get past this title screen, I'm going to go to this. This was from our presentation last Friday. I was showing you that this looks an awful lot like correlation, except for the fact that for the X and the Y columns, we have taken the averages. So for this particular set, we added up everything here, okay, and then divided it by, well, how many entries are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So obviously there is n equals 10 here. And if we divide 79 by 10, we just simply move the decimal over. So the X bar would be 7.9. That's how you would figure that out. Same thing goes here for the Y column. We added up everything in this row. I'm sorry, column. We added up everything in this column, sorry. And then we will divide it by 10, since we know that's our n. So we found that when we totaled it, sigma y was 56. If we divided that by 10, we're just moving that decimal place over, so it'd be 5.6. So this was the example I gave you in the PowerPoint. Now I'm going to return to a fact pattern that we did earlier last week. Hopefully you'll remember the fact pattern, but I'm just going to show it to you so we have a little bit of variation. So it's on the next slide. So let's see. Okay, here it is. This was the correlation practice I gave you when we were doing a fact pattern that involved stress and sleep as the variables. So stress was the X variable, and Y was and sleep was the Y variable. Okay, and here's all I did today. We're going to follow this one along. So all I did was, okay, this time I just put the n down here, n equals 12. So what did I do? Okay, you've already seen this fact pattern, so you might be able to recall. We add up everything, so we get sigma x is 65. What do we divide that by? Well, to get the average, because remember x bar, anything with a bar over the top of it is asking you for an average. So we're going to go ahead and if we add these all up, 65 divided by what? Okay, n, which in this case is 12, would give us 5.42. Same thing with the y column. We add everything up, and we got sigma y, which is 66, okay? And if we divide 66 by 12 to give us y bar, and remember, anything with I couldn't put the little line over it, so I had to just simply say y bar. I wish I could somehow put the little bar there, but I haven't figured it out yet, but I will someday. Okay, so 66 divided by 12 is going to give us a y bar value of 5.5. So now what I'd like to do is, again, taking this fact pattern that we're looking at right now, go ahead and go through the through the calculations rather, to create the simple linear regression equation, and I'll do that on the next segment. So what I've done here is I've gone ahead and transferred all of the values from our previous slide up in the text box to the left, and what I've gone over the drawing text, or the drawing box, I've gone ahead and put down the base equation for simple linear regression, and what you can see is it's y prime equals a plus b x. Now you might say, okay, what's a? A is a y bar minus b, that's supposed to be, there you go, x bar. Okay, and then you might say, well, okay, well, that's great, what's b? Well, b is, okay, and this should look really familiar. It looks like kind of what we were doing for correlation, and it should, except for those two things that we don't see that we saw with correlation. That the first one was the square root, okay, and also the y box. We're only dealing with the x box this time. So I've gone ahead and put in the numbers. So you see n, anywhere there's an n, I put a 12. You see sigma xy, 311. Okay. You see sigma x squared, 403. There it is. Okay. And then of course on the numerator we'll just go with this one too. Okay. Sigma x is 65. Sigma y is 66. Okay. And then of course sigma x squared is right there. So now we just have to do the calculation, which really doesn't take too much time at all. Okay, I'll just go ahead and pull up the calculator. Okay, there it is now. Move it off so you can see a little bit better. Okay, 12 times 311. Okay, let's go ahead and insert that here. 3,700. Okay, I think it was 32, wasn't it? Yep. Okay. And for the numerator continued, we go 65. So we're right here right now. Okay, 65 times 66. 4,290. It's an interesting 9, but we'll go along with it. It's just like that's an interesting straight line, right? Okay. All right, we'll go up here again. Okay. 12 times 403 for the denominator. Okay. 4,836. And finally, 65 squared. Okay. 4,225. Okay. Well, we don't have to do much more, do we? Okay, we're going to go 3,732 minus 4,290. Okay. Gives us an expected 558. Okay. 4,836 minus 4,225 for the denominator. 611. Okay, so drum roll. Okay, 558. We'll make it negative to be consistent. Divided by 611. Okay, that's negative as we expected. 0. A little harder here. 91. Okay, because I don't think we're going to be rounding that one up, are we? Nope, of course not. Let's see. Okay, so this is effectively going to be our b value. Okay, remember the b equation. Okay, we started up here. Okay, worked our way all the way down. So I'm just going to go ahead and say, I'm going to change the colors for us just so we can get a little spicy. Okay, it's going to be negative. Whoops, there was no. Here, look at this. I can do this now. Okay, all right. Okay. Great, now we're looking for what we need to find, which is the A. And the A, I'll go ahead and move down here a little bit so we have a little more space. We need more space, we can always get more. Okay, A equals, okay, you can see up here, Y bar. Y bar is going to be 5.5. It's a big dot. Okay. minus what? Well, look at this, you guys. We're going to go ahead and see that this is the b right there. Okay. And times, x bar is 5.42. Okay. Okay, I hope you remember PEMDAS. Please excuse my dear Aunt Sally, or whatever else you did to remind them. We're going to start with the multiplication first so that we can move through that. Okay, I'll move that over here first so you can get a clear angle. Okay, right here. So we'll go like this, 0.91, and it's negative. That sounds right. Times 5.42. Okay, negative 4.93. So watch this. We're going to go like this. We're going to go 5.5. Okay, minus, and we'll just put this all in one term, negative 4.93. Did I get that right? Let's see. Yep, I did. So what do you do now? Okay, we have negative a minor, we have subtract a negative number. So what are you going to do? You're going to add. Okay, you must. That's how this order of operation things works. So two negatives can equal positive. There we go. Not real pretty, but we'll do this anyway. .43. Okay, so I'm going to go ahead and, because I did it before, change color. Okay, just going to go, now that we have that done, we're going to go, our A value is going to be 10 point, at the point 4, 3. Okay, I think we have enough now. So I'm going to go ahead and change the color one more time. Let's go ahead, let's pick something interesting. Let's go with this one. Okay, so here's going to be our final equation. It's right up here. So I'm going to take it right down here just to give us more space. Y prime equals, okay, what was our color we use here? Red. Okay, here it is where the A was. We'll put 10.43. Okay, and we'll go back to that just to get this going. Plus, okay, because we're following the original template. Okay, and now what do we need to do? We need to put the B in the B score. Okay, and remember that, okay, it's a negative, so we need to capture that. So even though we have a positive there, okay, in parentheses, we need to put the full score. Okay. Okay. So at this point, you might be asking me, okay, what's next? I think we figured it out, right? Well, we did. We created an equation. So now what this gives us is an equation by which, for the correlation that we found, okay, which is a negative one, and so even if we look back on this sheet, okay, there is an imaginary line going through the x and the y, okay? And in fact, it's going to end up being negative because that's exactly what we found on this one. So if I come back here, okay, and I'm going to actually shift over to black to set this off. So what this looks like is this, okay? Here's our scatter plot. X, Y. Okay. There's an imaginary line called the line of best fit. I'm not too worried about it right now, but you already know that this is going to be a negative correlation because we found that last time we did this problem. So it's negative. Okay, not a very good straight line. Okay, basically what this equation tells us is that if we plug in any x along here, okay, it's going to give us the y value too. So any value I plug in for this x, let's just say, for the fun of it, let's just go ahead and say 6. Okay, so I'm going to keep it at black. Okay. 6. Okay. Everything else remains the same. Okay. Plus, I'm like I'm reciting it backwards, but whatever. Okay. So let's pretend I plugged in a 6. The question ultimately is if I do plug in an x of 6, so here's the x of 6, what do we expect to find approximately in terms of the line of best fit for the y? So here's what we're going to do. We'll just move this over and make it really clear. Clear this out. 6 times, okay, again, we're going to be very crystal clear, 0.91 negative equals, okay, so it's effectively in here going to be negative 5 point, what do we say, 46. Okay, so once we multiply the 6 times that, okay, then we'll go ahead and I'm going to say 10.43 4. Oh, there we go. Let's try this. Okay, so 10.43. What are we doing? Adding. Okay. What are we adding to? What are we adding it to? 5.46, but it's negative. Okay. So what is it going to be? 4.97, close to a 5. So here's how this is going to look. Okay. Y. Just put it off to the side here. So actually, no, we won't. We'll keep it here. 4.97, which is really close to a 5. So what did we learn here? If we plug in an x of 6, we're going to find a y value of 4.97. So if we plug in, okay, again, an x of 6, let's just say that's right there, okay? It's gonna, too bad I can't do little dots. Yeah, I can. Okay. In theory, it's gonna hit right here on the line, and then it's gonna be, come on. That's been the hardest part today, getting these little dots. Okay. Nine, 7, which, it's supposed to be a 7. That's supposed to be a 9. Goodness gracious. Oh, goodness gracious. We could have just said 5, huh? Okay. So if we plug in a 6 at the on the x, okay, right here, if this 6, if we plug that in, this equation tells us on this particular correlation, we should find something akin to a 5. Sorry about the mess I made here, but you can kind of see where we're going with all this, hopefully. Again, this is what a simple linear regression can help you do. It can help you once you've already established that a correlation has statistical significance in either the positive or negative direction, you can now begin to isolate specific points. That's what it can really help you do. So it's like a statistic on top of a statistic, huh? All right. Well, again, I didn't expect magic here. I just wanted to show you what this looks like real time so you can get a feel for it. We'll do a little bit more with this, but again, you have a test to study for. And frankly, this is not going to be on it. I'm not going to have you you're not going to be doing this on the test, not all this stuff. However, you're going to know what a regression is. That's the important thing. So, okay. All right. We'll talk soon.